So this is Chisel's best practice. My name is Chick Markley, and I'm here with Edward Wang again, and we are going to talk about best practices. My bio a little bit. I'm the staff at the Adept Lab here in Berkeley, and mostly what among the other many things the staff do. There's a few people like Jim Lawson and myself that we are sort of in the position of maintaining stuff that graduate students produce. Graduate students come and go, but we don't necessarily want their software efforts to come and go as well. So for the projects that are really have some legs, that's what people like myself are part of the team that tries to keep them up and running and be able to maintain them and also train the next generation of developers who work on them. Mainly I work on Chisel, Fertile, the testers, and I've done quite a bit of work on the DSP tools library. I authored the Fertile interpreter and the Treadle. These are two Fertile-based interpreters, so they form the default core of our unit testing infrastructure. So they are not super advanced. This has a lot to do with the fact that I am not a super advanced hardware engineer, and I'm sort of learning it as well. But they are, I think, pretty good, and they're a good start, and they give a lot of good access to things. So hopefully we'll get to some of that. Like I said, I don't I don't develop Chisel code. I don't build circuits. I support the language that all of you hopefully will use to do that. And so in some sense, most of what I see in answering questions and trying to figure out what's wrong or fixing broken Chisel code is I see the worst practices. I see bad methodology, I see misunderstandings, and I see bugs in the underlying code. So as I was trying to put this together, I just really, that's somewhat of an anti-pattern. I am not the right person for it. But nonetheless, I'm going to give you my opinion on that. And I want to say that one of the things that we think we've done with Chisel is we've tried to bring software sensibilities to hardware design. And so really, what I'm going to tell you here are all things that you could look up yourself, and anything that's sort of the fundamental principles of software design today filtered through some old guy who's been doing it for a long time. Best practices, Edward even covered some of this. Start from templates. Initially start with the ones we provide, but then probably you're going to want to build your own that have environments that are set up the way you want. You want to incorporate tests from the beginning. That's a TDD, test-driven design, really important. Document your code. Those of you who are software developers should know this already, but it's never a bad idea to remind yourself it will pay off in the long run for you and anyone who follows after you. Follow coding styles. This is a pretty big one. I think it's worth it, and I'm going to go into each of these. I'm not going to belabor them, but we'll go through a little bit more. Have a code management strategy. Software code management is better than it's ever been in history, so take advantage of it. Don't repeat yourself. This is a coding principle that's very important. Number 7 is don't repeat yourself. Keep that in mind, okay? You need to grok Scala land versus Chisel land. So even though these are, they're one and the same in some sense, or they're different faces, they are two different languages, and one is stuck in the middle of the other. It's really important that you develop, if you're going to be a Chisel programmer, that you understand the distinction. And we are ourselves struggling to how best to describe that, and so to try to transfer that knowledge, and I'll try to touch on some of that today. The collection libraries, we talked a little bit in the previous session about stamping out lots of things or having highly regular hardware stuff. Scala was born to do this, and the collection library is the mechanism by which it is accomplished. So you are doing yourself a big favor if you learn the collection library. And hopefully we'll see some examples of that here. Use an IDE. Tools have gotten better. One would hope in the last 30 or 40 years of software development. I still use VI myself. You can do that, but there are better things out there. And then share your knowledge. There's a lot of different levels in which to do that, but it kind of goes along with the code management. There's lots of ways to contribute to stuff. There's lots of ways, and that can be simple, like just pointing out errors in our documentation. You can also fix those things yourself. You can point out flaws in our code, or you can even fix those things yourself if it's important. So consider all of that. Yes?
I don't know if you want questions throughout the whole thing.
Yeah, let's go for it.
Do you have a recommended style guide for like, sometimes
Yes.
when I'm first looking at Chisel, I don't know if I'm looking at a reg or a wire. And sometimes it's good to think about it that way.
And I'm not sure that our style guide covers that, but we do have, nominally, there's a style XML thing, which is incorporated by some style checkers that could be used on Chisel code. I recommend using that. Those are distributed with the repos.
Okay.
And so you can look at that. There is also, I think, a section on our wiki regarding stylistic considerations. This is another best practice which I learned yesterday from the Google folks, is to have your own Chisel support team. I think it's a great idea. I don't know if that's practical in all cases, but if it is practical in your situation, I would encourage you to do it. Edward mentioned the templates. These slides will all be available, so you can find that. And I think roll your own is ultimately where you probably want to be. But in the beginning, I generally, like if I get a question on Stack Overflow and think to make sure I understand the question, I'm going to re-implement what they see there. I usually just go to Chisel template, I make a little thing, and I cut in their module, or I wrap the snippet in a module, and I try to figure it out from there. Test-driven development, tons of stuff written on it. It's a good idea. It's just simply a good idea, so do it. Document your code. Scala doc is a style of documenting functions and methods and things like that, and there are tools that automatically build that into an API guide. So it's really worth doing that particular.
Maybe we can show the Chisel API webpage.
Yeah, actually, I think I have a.
We have that.
Okay, so anyway, yeah, so this is typical API documentation. On the left this is just essentially a comment that follows the Scala doc style, and so the Scala doc compiler will scoot through the source code, find the stuff that around functions, and then generate this sort of thing over there. This is just a small piece of what it does, but it's a good idea to know that, and if you look through any Chisel code, you'll see some examples. GitHub has a wiki on it. We tend to use that a lot. I mean, wikis are a dime a dozen, and so it's just, and sometimes silly not to put distilled wisdom that you have from your projects into a single place. I would highly recommend it.
I think one thing, if we go back briefly on one slide, so you can see over here on the right, there's the short user's guide to Chisel. So basically, whenever we have users have a question, can I do X in Chisel? The answer is it's probably on the wiki, and if it's not, then it's our fault. So
right.
I highly recommend the wiki.
Yeah. Do stuff with style. There's always, like I say here, there's a lot of debate about style and how important it is, and I'm super reasonable about it, and I'd like to settle it here, so I'm just going to say it does matter. Pick something, really. I'm going to say that following the conventions is good. It reminds me, I used to, with a friend of mine, we would go driving through Death Valley at like 95 miles an hour in my old Land Cruiser, and my friend would just look out the window and go, iguana. And so he would see an iguana, like some 50 meters or more off the road, and we, slam to a stop and go over and catch it and play with it a little bit and then let it go. Probably we're only going 55, actually. But there's a whole thing about pattern recognition. His eye had trained, so driving down there against the background of a rock, he could see that lizard. The analogy is strong here, is that if you follow a coding convention that is similar to the stuff that you're going to be living in, and in this case it's Chisel code, you will be well served to use the same style as the Chisel code, and the reason is because you will be able to read the source Chisel, and that will help you a lot as you advance, particularly as you go to more advanced stuff, or if you want to contribute back to the project.
I think maybe a little bit of nuance I'd like to inject into that. I think I do agree with the general sentiment here. I think the one thing is it can also be unproductive to get into debate about 2 spaces versus 4 spaces, and like silly things like that. So just pick a convention and follow it, but we don't want to be religious about it.
Right. I personally vastly prefer the Python variable naming things with underscores, but because of this thing, and because of the environment I'm in, I use the camel case Java style stuff. It makes it easier for me to read other people's code, which is really important for making me a better programmer. So just throwing it out there. Use Git or something better. I mean, I don't want to get into religious wars about that either, but the modern code management is just incredible. The ability to branch and combine and track and squash the commits together, all that sort of stuff. It's worth, if you're going to be a Chisel programmer, a real Chisel programmer, which I don't know if that's true of all of you if you're just assessing it, but you can pass it on in that case, is we are bringing all these tools to bear on a problem of generating hardware, and we're bringing software tools to that, and so this code management is a big one. Use PRs. So PRs are, I'm drawing a blank. What does it mean?
Pull requests.
Pull requests. Use pull requests even for your own code. If your team size is greater than 0, so you even PR your own stuff, you'll see regular things where things come in a known way, and there's tools for looking at that. The history will be super valuable to you. And code review is, it's a chance for everybody to get together and, to see what other people are doing, to make sure things are doing it right. Even if you review your own code in a dispassionate way, is looking at it, here's a bunch of commits that I want to put in, you will often just see something and you go, oh, dang, I should not have done that quite that.
I think to make effective use of code review, the goal is not to be a bureaucratic nitpicking process. It's more just a review process rather than we're gonna spend 5 hours dissecting every second line and writing 1,000-page essays. That's not the goal.
That's not the goal. I'd also I was thinking about this morning randomly, but another thing that I do occasionally, and I it's a great opportunity for me, is sometimes it's a good idea to work through a problem with somebody else coding.
I think they call it the rubber duck programming.
Pair programming.
Pair programming, or one of the variants of extreme programming and stuff like that. I think that can be really productive, not just for the code you're working on, but sometimes you see the techniques that other people use. Or like, oh, how'd you find that? It's just like it's a good way of transferring knowledge, and so transferring knowledge is ultimately what all this is about.
And by the way, we're not saying you should we're saying these are kind of tricks that have been useful in certain scenarios. We're not saying do it 100% of the time all the time. It's apply these techniques as you see fit.
Okay, so this is I'm going to reiterate, don't repeat yourself. So the search term is DRY. When you're writing code, if you find yourself writing the same code more than once, or if you're cut and pasting a lot and using the same code over again, at least consider the possibility that you should be putting that code in a place that can be reused automatically.
I think the one useful tip I've heard is the rule of 3. So if you find yourself pasting a piece of code more than 3 times, consider refactoring and making it a function or something. So I personally really like the rule of 3 because it's very simple, easy to think about.
Okay.
Because sometimes if it's really just only used twice, then it can there is some amount of overhead in refactoring. But generally, the rule of 3 has been pretty robust.
Right. So a couple of concrete examples of that here is in Chisel. If you have IOs on modules that are all the IOs of this thing are being hooked up, or some reasonable subset, consider putting all those signals into a bundle, and then you can just use the bundle on both sides, flip it in the one case, and bulk connect it. That's a big win. In object-oriented programming and in Scala, we have traits and abstract classes. That's a good thing to put a bunch of code that is going to be used for certain classes of modules, and that you can then derive the new module class from your trait or your abstract class, and it includes all that code automatically. And that code can be parameterizable itself, so it can grow or shrink or modify itself depending on the parameterization of the module. It's a very powerful concept, and we've run across it a couple times already.
Quick question, just from expert's point of view, when is it good to use a trait as opposed to, I don't know, extending some other class or extending a bundle or something?
I think it's good to try to use a trait, actually. I think it's a good default starting place, and traits have limitations, and usually when you hit the limitation, that's a reason to go to an abstract class or something more.
The one thing is, I don't know if Scala actually lets you extend multiple classes. I know you can mix in arbitrary numbers of traits, but
that's a reason for doing traits, is that you can mix in more than one trait.
Yep.
So it would be like if I had traits from a bunch of different projects that at one point were never really connected, but my next project uses them. That's a good example of when to use traits, or?
Well, I think when to use it.
So one example that I've used traits is like, let's say if I have I have a bundle, right? So like I have a bunch of a family of bundles, and they happen to share like a bunch of common IOs, but then each of them also kind of has their own like additions on top of that. So what I might do is I might take the common IOs and put them into a trait, and then I'll create a bunch of new bundles, and then I'll mix in, or I'll use with my common bundle, and then I'll kind of mix in that, so I don't have to copy and paste those definitions over and over again. The nice thing about traits is that, let's say, imagine if I have my common bundle 1 and common bundle 2, I can do my new bundle with common bundle 1 with common bundle 2. Whereas if you use extends, you can only extend one of them. You can't extend both. But with traits, I can just mix in n pieces of code, which is much more powerful.
I just wanted to make a point that I don't know Scala so well, but in Rust and in Haskell, the equivalent of traits in both of those languages are sort of the default, and there is no such thing as inheritance in either of those languages. So I would agree with the point that you should always prefer using traits when you can, and the one time where you would end up using base classes is typically when a library has already organized itself that you need to subclass in order to get the behavior you need.
The current weakness of traits is that they're not parameterizable directly. There are sort of some mechanisms for doing it, but sometimes that's a weakness if you need.
Could a field within a trait be parameterizable, like a bus width?
Right, and it might pick up implicits, I think. But it does get a little bit more complicated. But traits can contain, not just data elements, but also methods that apply to them, which is pretty handy. Also, this isn't strictly in the DRY part of it, but traits are a great way of taking some data that you have and making it distinct or detectable in match statements and other places. So, like,
have we introduced match statements yet?
I will.
Okay.
Traits, if you have a data, like one of the problems we've had with Chisel in the past is that integers are all over the place, right? So an integer could be used as a width, it could be used as an initial value, it could be used as a reset value. It could be used as a breakpoint. In Chisel, we got away from this and saying this is too confusing because people can't tell when I just pass an integer parameter to something what it is and whether it's.
So there's a very classic example of that. So in Chisel 2, you could write uint brackets 3. What does that mean? Is that a uint of literal 3? Is that a uint of width 3? What is that? So it was very confusing, right? Just uint 3, what is that?
Right, and it turned out it was a uint with a width of 2. Because it looked at the 3 and said, how big is this thing? Well, this is 3 can do 2 wires, so I'll make it a width 2. Yeah, it was very confusing. So there are a lot of times in Scala, you have collections of things and you don't know the type. You can, if you declare your variables and add a trait that says these are all related, then later on you'll be able to pluck those out and know when you got one. Or you also get a compiler error if you pass the wrong kind of thing into something.
Yep.
So it's, I'll see if I can come up with an example while we're here. And I'm going a little fast right now because after last thing I would like to try to get to maybe a little bit more deep dive into code. But there's a certain speechifying that I just have to do. All right. So this is the Scala land versus Chisel land is sort of the metaphor we use. I think it is getting better. The bottom rule, sort of like the trait thing, is you want to work in Scala as much as you can. Organize your thing, figure out what you need, collect all the things, and then you can sort of think of it as use the Scala to populate hardware in your module. And we'll try to come up with some examples of that. But
I think one way to, from a hardware designer perspective, one way to think about Scala land versus Chisel land is it something that is it about the way that I construct it, or is it about something that's, for example, going to happen in the hardware itself? Let's say you consider the case of if statements versus when statements. They both sound similar. One of them is Scala land, one of them is Chisel land. So the way I think about it is a when statement is constructing hardware. So if I needed to change like on demand on the hardware itself, then that's a mux. So I think when statement is like building hardware, it's like building a mux and building a thing. Whereas if I write an if statement, then that's kind of like, if this is true, then I'm going to put this module. If that is true, I'm going to put this module. And once I put it in the chip, it's going to be fixed. It's not dynamic.
Probably one of the more common gotchas of a new Chisel programmer too is you use an if and you see both blocks.
Yeah.
But in the if statement in Scala, only one of those blocks is going to work is going to be run and generate hardware.
One
if
of those,
you use a when, both blocks are going to be generated and they will be wrapped appropriately with muxes so that everything happens when it's supposed to happen.
So it's like an if statement, it's like you're putting this or this. With a when statement, you're putting both and then choosing it with a mux. Right. So just think about it from a hardware designer perspective. Am I executing a recipe for putting this or this, or am I putting two pieces of hardware and building a mux? It's critical to know what you want to build.
So is there something that catches that? In other words, if you have an if statement on something that's actually a dynamic variable, what happens?
It's not a compile time. I mean, usually that's a pretty obvious behavioral problem.
I mean, if you do like
so usually it's caught in unit testing. I would say it's a tough error to catch because
the compiler will catch some of it. Like if you use an if like 3.u equals io.x, like the compiler will yell at that because that returns a chisel bool, not a boolean. Like the when statement takes a bool, and if statement takes boolean.
Yes, that's true.
Yeah, so the compiler will catch.
But the opposite is actually the more common error, and that is when you use an if when you meant to use a when, and you don't get both forms of the hardware generated. Yeah, there's not a really. It's hard to imagine what the language construct would look like that would catch that. But I think.
Well, actually, so the one thing I think the type system does catch all of that. Right? Like one of the things is new users ask us, what's the difference between bool and boolean, int and uint? Like we get asked those questions a lot.
Sure.
Right? And the answer is like if you try to use an int where there's supposed to be a uint, you're mixing Scala and Chisel in a bad way.
But if you don't generate a piece of hardware because of an if, you just won't know until you unit test.
So
I think unit test is probably the best. Yeah. It's sort of like a coverage thing. And usually the result is fairly dramatic, and at first it's confusing, but then once or twice and you get it. Another typical thing,
Sorry, unit test there meant a Verilog unit test? Or
no, I meant
test?
Scala.
Okay.
Unit. Question: is there a thing like an X? I mean, like in Verilog we have 1, 0, and X.
We don't use that in the Scala-based unit testers. Verilator does some support for that, or
I mean, Verilator, like basically Chisel generated RTO like will not introduce X's. I think for all testing will be like randomized. There was 0 in it. With regards to X's for kind of marking like values as don't care, we have a don't care that allows the Fertile compiler to make optimizations and optimize away logic.
Right.
So our closest equivalent of X is don't care.
This is somewhat of a religious war that was the early skirmishes were won by the non-X side in the Chisel development camp. They were sort of very discouraged. I think as we're getting broader adoption, this issue is coming up again, and I think we're all looking at what we should support and so I think we would value input into that thing. But right now, for the most part, we don't use X analysis or Z.
I guess so the way I would describe it is at the Chisel level, we have don't care. Like you can assign values to don't care.
Right.
And Fertile can use that to make optimizations. But when we emit to Verilog, we will not emit X's.
Right.
That's our policy.
Right. But people use X's to figure out whether some wire has been set in some case.
It's a very powerful tool for finding.
No, it can be. I agree. I agree.
So
I think we do have our own.
Yeah, Fertile will actually catch uninitialized wires. So we have a compiler pass, like let's say in your Chisel, if you forgot to initialize some wire, it will yell at you and say, hey, you didn't connect this wire. So we have analysis passes to catch those.
Right. Yeah. I think it's not that dire in the sense that because of the way we build things, we tend not to have that class of error in the same way that I think traditionally happens. And so, but at the same time, it is in terms of tooling and other things, there is some call for it. So, but at the moment, the answer is generally no. We don't use X's. The Fertile interpreter does track like things that have been unsigned, but I think that with the don't care stuff, that's largely not been in play.
So has Chisel3 made improvements on representing don't cares in the language, or Chisel3?
Yeah, Chisel3 has had additional stuff. There's annotations now and a don't care thing that you can assign to a wire.
So let's say if you have an output of a module that you just don't care about, you can do io.out : don't care.
Right.
Oh, I saw that. But for a logic minimization of let's say decoder cones or something like that, is there a construct to assign to wires don't cares?
So in Fertile you can have void. Fertile has a concept of don't care, right? like Fertile has void, we just don't care, and so it can do optimizations at the Fertile level. We just don't emit the excess to Verilog.
I probably want to ask about that.
Yeah, I think we did.
Yeah, we can maybe take this in depth offline.
All right, and I'm not totally sure that you and I are the most competent people to answer that question if you want to take it further. And so back to where we are. VEC is another good example. I think is a lot of people want to use VEC early and often, and the answer is don't do that. There's only two reasons, really, in my opinion, to ever use a VEC, and one is in your IOs, you need like 40 uints to be all in a stack together, and the only way to do that is with a VEC, or short of writing down 40 uints. The other one is if you want to dynamically access a member of the VEC. So that means you're going to use some other wire as an index to which value out of a VEC that you want to take, then you need to use the VEC stuff.
Think register file.
Right. But otherwise, you should be using sequences or some other collection type in Scala, because it means you have access to all the pieces of hardware you want, and you can use the Scala to hook them together and to stamp them out any way you want. And that's that. So anyway, Scala versus Chisel land is if you were going to be a Chisel programmer, this is something that you're going to have to master. It's just, we try to make it as easy as possible. We try to refine our documentation continuously, but you have to internalize this difference, and it's a very important thing to do. Collections, in my opinion, if we could only do one part of Scala, this would be it. There's so many ways and so many tools, and what they haven't killed the off by one error, but they have nearly killed it. There is, if you get off by one errors when you're writing Scala code, you're probably doing something wrong. You're probably not using good technique, and it's not a matter of keeping track of whether you should be using the -1 or an until or any of that. You shouldn't make mistakes with indices in Scala. So I'm sure there's some pathological counterexample, but it's not. So I just throwing up some things here. I started to say what was indispensable, but I would say in general, almost every method in the Scala collection has its use, and you probably are going to encounter that use at some time.
Map is the other main one that I.
Oh, did I put map there?
Yeah, I use map.
Is so
What's
fun.
the difference between reduce and fold? In some language, I think those are synonyms.
In fold, you get to specify an initial value. So one of the good advantages of fold is it works with zero length lists.
Whereas reduce will crash with a zero length list. Because it doesn't have initial values.
Sliding, I think, is really cool because it lets you, if you have some data, it lets you take a window of that data. So if you say Scala 2, you get the first two elements and then the second and third element and the third and fourth. So it's a really handy way of connecting like multiple rows of things together. It also has a second parameter which lets you skip, so you can take elements 1 and 2 and then 3 and 4, and it's a really cool. It's notationally it's a little tough because the things you get, at each thing are lists, which is a little confusing sometimes, but it's a very powerful one. I don't know, I've just always liked it, having it available. But map is critical, reduce, fold. Indices, you should, I still see even some examples I saw down there yesterday. Indices is like, if you have an array, indices is the set of indexes. And so you can iterate over those. So you should never say, 0 to until the length of this thing.
Or the worst cases have a var and then I plus one.
Right. Any of those, just if you have an array of A, just say a.indices dot for each, and that way you'll walk through every index of the array.
The other really cool thing I like to use is zip with index.
Yes, that's a great one. So you have a collection of some sort, and in the block of code that as you access that array, you want to also know which index you're on. You just say array.zipwithindex for each, and then you give it a tuple and say, here's the element of the array and the index of it, and then you can use that in the body of your loop.
Yep, and don't have to think about until versus 2 versus +1, -1.
Okay.
None of that.
All right. I'm going to say it. Use an IDE. Vim and Emacs both have very nice Scala extensions. IntelliJ is better. Eclipse has a lot of nice Scala features, some pretty powerful ones. IntelliJ is still better. I assert that I remain a productive programmer. My short-term memory is vanishing, but because of IntelliJ and the ease of which I can discover the methods on objects, the origin of various types that I'm using, and go straight to the source, it keeps me functioning. So I should say that I also am personally a big fan of IntelliJ, in case you weren't sure. So I really strongly encourage it, and I will try to give you some examples of that here. Looks like maybe. So that's the end of this producer-consumer relationship that we have right now. So I'd like to kind of go forward from here and just sort of bop around. I don't know if so I have some ideas for things to talk about. Collection mysteries. There's a couple things that work really nice. The reduce in Scala is great, and it works on hardware. Sort, which looks arguably just the same, doesn't work in hardware. We've got the VEC issues. We've got some things. I'd like to go over match because I think that's really important. Metaprogramming, the reg family. I think that's a good one to talk about, reg and wire. Parameterization, you're probably more familiar with that than I am, but I think that's a good thing. We can think of a couple examples of that. So
the bootcamp also has lots of examples of all this
right.
code.
Okay.
So maybe we could just ask the audience and see what they would be interested in seeing.
Right.
And we can
I want to just sell a couple more things to put it on the radar, though, is that a lot of my debugging is, as I said, somewhat problematic, as I do a lot of helping of new users and things. But also, when I'm debugging, a lot of times I'm trying to figure out if is there a problem in the Chisel as well. So my techniques are maybe a little bit different, but on the other hand, it might be interesting to look at a little bit of what the tools are for that. Module versus hardware generator, yeah, that's not that. Decoupled stuff I think is important to learn. The diagramming, I think I have a slide or two on that. So anyway, I kind of like to maybe go with the will of the group here and see if there's any particular areas you guys would like to look. I mean, I think it's a good chance to do hands-on and then discuss what we're looking at on the screen.
Yeah. It'll be much more interesting if the topic is something you all are interested in rather than us blabbing.
Yeah, I guess I'd be interested to hear more about the Scala collections. I find myself kind of overwhelmed with like all the different collections that I could use. It seems like I've used like a bunch of them and they all get the job done, but I don't really know what collection I should use in what scenario.
Yeah, I think the answer to collection, okay, there's two parts of that. One is the collections themselves, right? So Java has or Scala has a rich family of that. You have seeks and arrays, and then there's array buffers and lists and all these different things. I think in general, you probably want to use a seek.
What are seeks?
Seeks are sort of a generic type that doesn't insist on a particular implementation.
So I think it's an enumerable or of some
yeah, it has certain list of certain properties that.
Yeah. So to refine that, like, there's kind of like two parts of seek is slightly overloaded in Scala. So there's the seek as an abstract class or an interface, and then I think the default implementation of seek is a list. It's an immutable list. That's the default implementation. So okay, so basically, like you can imagine in Scala, the name seek is shared by two things. There's the interface, abstract interface seek, and then there's the default implementation of seek, which is an immutable linked list.
What do you mean by default implementation?
Like if you, let's say, do like...
You could say new seek.
You can do new seek brackets 1, 2, 3, and then I create an immutable linked list of 1, 2, 3. But you can also use seek as a type, and that refers to the abstract class.
So if you use seek as a parameter on a function, for instance, you can pass an array to that because array meets the interface specification for seek.
Yep.
And so it doesn't care that you passed in something that wasn't an immutable list. It's using it as a...
If you have like a map or something, I'm guessing you can either turn it to the sequence of values, the sequence of indices.
Yeah, so anyway, to answer your question, so the first thing is, when picking lists, it usually doesn't matter that much. On the high end, and maybe like if you're actually building fertile passes where you have very large collections of things, it might matter whether you use a list or an array because of implementation details of like one's faster than the other if you're adding to the front or adding to the back. Yeah. But in general, I would say it doesn't matter that much. You know, seek is good, lists are okay.
We also have vector, which is array list.
Yes, yeah. If I'm building a list of things, I typically use array buffers. They're easy to add to the end of. Lists are easy to add to the front of, but notationally, there really doesn't matter. And if you're usually in a Chisel module and you're making a list of less than 100 things, it probably doesn't matter.
One thing is I should say, like often I actually use construction. Like I will use collections functions to construct lists. Let's say like if I'm taking like a list of strings and I want to create like, let's say I have a module that's parameterized on that and I want to call like new my module on each of those. I'll do something like my strings dot map brackets module new my module brackets underscore. So basically I'll kind of construct my new array, my new seek of modules using a collections function rather than with a for loop and array buffer. So often I find compared to when I'm programming in Python or Java, I don't need to use mutable collections as much as I do in those languages because I can use map, reduce, and all these functions to construct my collections.
I was going to try to look at some examples.
Can you talk a little bit about why you don't use scan that much? Are you trying to move away from it, or?
I just find the semantics of that one confusing. It's a personal thing.
Never understood scan either.
Pardon?
I've never understood scan either. In Haskell, they have a scan. I've never figured out when.
I think the scan is sort of it's like map in a sense. I mean, you get a collection back with scan, right? But you've looked at all the entries and done something to them.
Yeah, but I think you get one extra entry or something like that.
Yeah, I don't know. I think there are UK. I think it was an example even yesterday, maybe. Let's see. Do you have any? Can you think of any good examples?
I mean, the worst case is you just spin up the bootcamp and write some stuff, and it's not that difficult to write.
Yeah, that's true. Yeah, and for collections at first, we'll start with that.
So actually, I thought in the intro to Scala module, we actually have there's Scala collections in there.
Yeah, no, I think it's repeating yourself is sometimes useful.
Well, the time that you want to, because one of the things that you do when you learn to program is you learn to dry out your code, but then one of the drawbacks of that is if you dry it out too much, you've now coupled that code together.
Yeah.
So you want to duplicate certain things kind of judiciously.
Where do you think it was?
I think intro to Scala.
Has the collection stuff?
I'm not sure, maybe. There's conditionals, methods.
I think it might be in.
What has lists?
Okay. Yeah, lists. I don't know
if that is. I think there's a separate collection.
I think there's a separate collection.
3.2. That one.
Yes, there you go.
That one has more collections.
It's named collections. So.
Yeah.
All right, so collections.
Oh, there's an example of a seek.
Yeah, so this function takes a seek event, which really you can pass just about anything that is a iterable collection of integers. Here's an example here, which is a collection method, which is indices. So taps is a list of things. So this gets every index, and you can just do taps at I. That's not super interesting.
Are there any collections that have non-determinism associated with them that should be avoided?
The answer is yes, and it has to do with, one of the other things that you use, that I use a fair amount is maps, like hash maps. So, and then there's linked hash map, which I think the keys are ordered. Insertion order.
Yeah.
But for some reason, I think if you use the keys method to get what all those keys are, the thing you get back is a set, and the sets are inherently unordered.
Yeah.
And I know that this mostly for the Fertile team, I believe, but they've gotten bitten by this a few times. You know, they create this linked hash map, and they know that they can iterate through them in order. But if you actually extract the keys from the map, you will get an unordered set. And I think there's a workaround for that.
I mean, one workaround is just sort the output.
Right.
That's the obvious workaround.
Yeah. So can we just create some? I don't know what's a. Okay. So getting anything interesting here.
create a new cell. And
Yeah, that's what I'd like to do. But I think I should run this thing first to get everything loaded, right?
Well, I mean, this is pure Scala, right? So we don't actually need to, unless you want to build Chisel with it.
Not the first order. All right. It's chewing away.
This bootcamp, I think if we haven't mentioned before, it's online, open source, and we encourage everyone to check it out and work through the exercises.
So, all right. So, what do we want to do? Let's iterate over something. And how do you control? Yeah. Okay. So if we say list.indices, we'll get at that, but we can make that a list out of that. List.reduce. That adds them all up. So this brings the underscore operator, which is the source of some confusion in Scala. It means a lot of different things. In the case of the list collection, underscores are sequentially assigned to the arguments that are being passed to the stuff.
Do you mind if I show another example?
I tend not to do this, frankly. I'll let you show another example of it. So most of the time, if I was doing this, I would just go ahead and write this out very explicitly. And this is a function that takes two parameters and adds the two parameters together. And this is equivalent to what I had just done before with, thank you. What am I doing wrong, Edward?
Is it asking you to specify the types for A and B?
Shouldn't have to do that. Shouldn't do that. All right.
Do you use a case keyword there?
What? I probably don't, but you should. That should be okay as well.
Yeah, you didn't need the case. Because I think it was trying to like destructure A and B, but like
yeah. Anyway, so reduce, and this is I think a really I don't know how many people have seen this stuff in Scala before. So not many. So maybe we'll take a minute. I don't know if you want to do the example. So we talked a lot about in the don't repeat yourself portion of the program. We talked about like taking your code that's common and putting it someplace and sticking it, and that is great. There is another consideration though, and that is that your hidden things are happening, right? So when you do something and you inherit from something, you get a bunch of stuff and you don't see that. That can sometimes be confusing. I think one of the things that's interesting, and particularly about the collections, is with Scala, unlike a lot of other programming languages where you have all these loops that you're controlling and the order is really important, what Scala does is by wrapping those up into these list collection methods, it then puts the code that you want executed on each element of your iteration to be right up front and in the center with the iteration control reduced to something that is quite clear. So in this case, this code that's highlighted here is a function, and it's like this is an anonymous function, meaning I haven't gone anywhere and said def function, this is that, and all these sorts of things. This is just in place, in line, saying you have a function of two parameters, and that function returns the following bit of code, which is a plus b. And so what I've done is, so really here, reduce is going to iterate over every pairwise bit of elements in the list, or actually, well, accumulation, but and it's going to call this function on each of those pairs that come through.
So I mean, we can write out the more clunky version of this.
Yeah.
So again, languages without these anonymous functions, you have to do something like return a plus b, and then so that is kind of you can see it returns the same thing, but Scala lets you get rid of all this boilerplate and replace it with like something like 3 characters,
Right.
which is really
so
cool.
At first that's hard to read.
Sorry, in this case, Scala, and I assume Chisel would do the same. It's inferring a type for A and B.
Yes.
Yeah. So in this
type
anonymous function is inferring types. In here, I'm just explicitly writing it out.
Right.
Because I'm.
But you
defining-
have to actually
yeah.
if you do it explicitly.
Yeah.
But implicitly, it can figure it out from the context that an anonymous function is placed in.
So it's inferring a type. It's not casting it to, and you don't have to worry about that in Chisel.
Yeah. So
Some
actually,
weird
Well,
technique.
adding with something else like a floating point number, and maybe it'll work.
So if you do something like stupid like that, I think it'll error. See, like it's gonna it infers that A and B are integers, and then now you're trying to add it into a string, and obviously it blows up. So you can see that the type checker is also smart. It does its
Right.
job.
Yeah. So that's so this is like I was saying before, like learning the language, understanding notation. This idea of creating anonymous functions just where you need them that are very explicit to what they do in that one role is one of the more powerful aspects of Scala. It's also very important to learn to read that if you're ever going to read anybody else's code, because you'll find this stuff all over the place.
Can I showcase another cool
Yes.
thing about?
Yes, absolutely.
This is one cool thing about Scala's anonymous functions that you can't do in Python. So listen up. So you can do something like. And then we can actually return. So how cool is that? You can have an anonymous function as multi-line and using very concise syntax. So in Python, for example, they don't have multi-line lambdas, and this is really cool for like doing a lot of hardware stuff.
And debugging.
Debugging too. See, like right now, let's say if our anonymous function here goes wrong, we can just put curly braces around it and add print statements. Like that is very cool.
Can I easily print in hex or binary
Sure.
if I'm at that level of
Yeah, I mean, you can.
illustration?
Yeah, a lot of people don't know. So there's a couple things about strings, which this is all about things that you are likely to see. Edward wrote this in a particular style. There's another style here where if you if you put this thing in braces, and I got now you has to be. It has a Scala has a string interpolation.
String interpolator. Yeah.
So there's if I put an S in front of this initial double quote.
That's standing for interpolation, of course.
It means yes.
Yeah, it's interpolator.
String interpolator. But there's anyway. So that am I syntactically correct here?
Yeah, I think it's correct.
Yeah. So that works just the same. So, but there's an even more advanced one that I don't even know anyone else who knows this. Is you can put an F here, and then you can follow this with a percent modifier. So 04x. How about that?
Yep. Oops. Well, you remove the toString.
Oh, right.
It needs an int. Yeah, you can do that.
Yeah. Oops. Control delete.
Yep.
Yeah.
So now it's in hex.
Now it's in hex.
So previous example, just regular string interpolation. If you didn't have toString, would it automatically do that, or?
It would have done it anyway. A couple other things here. What is this? What is this? Just it's triggered some.
Sorry, okay, one more question.
Sure.
Can you expand a bit about when we think of lists or sequences in hardware so that I can mentally start creating this correct model in my head? So a list in hardware is, I guess I'm thinking of it as like a bundle or like an array of registers or something that I can iterate over in terms of printing out a circuit to do something on various bits of my bus. But
like you're saying, how do I use C collections to build hardware?
Yeah.
Okay.
I guess, do you mind if I go through an example?
No, go do it.
All right.
Well, let me do sliding first.
Okay, yeah, we got to show sliding first.
Okay, cool.
Yeah, we will get to that in just a minute, but we have to first show off all the cool features of the collection library.
I'll forget my short-term memory again.
So
this is the sliding.
So sliding returned a list of lists, and there's list 1, 2, list 2, 3, list 3, 4. So that's all the pairwise stuff.
Oh, that's so cool. I wish I knew that. Actually, there's sometimes you write code where you need to know also the next element, and that is so cool.
Right. Now, but you can also have it do,
Stepwise too.
Yeah, stepwise too, and then when we run that, you get 1, 2, 3, 4, 5, 6. It's just elegant. And you just think of this is not hard. Everybody's written if you're a programmer, you've written for loops that do all this sort of stuff, right? But there's +2s and, all this kind of stuff here. You just almost can't screw this up if you understand the concept of what you're doing.
Yep. Hear it straight from the expert's mouth.
Okay.
Can you scroll up one more time real quick?
Sure.
Sorry. Thanks.
Okay.
Yeah.
So let's talk about this in the context. Oh, that's what I was going to say is hardware.
Wait, before we move to hardware, can I show one more cool trick?
Okay. Oh, yeah. I thought you were going to show a hardware trick.
I'm also going to show the hardware trick, but I want to show one more collections trick first. Sorry, some of this stuff is like really cool. It's almost like playing a video game. Okay, so we have our humble list. So one really cool thing about this is that you can also chain these these functions like fold, reduce. These are called higher order functions. So we can chain them together like this. So first I'm going to do a map. So you can see map it takes every element in the list and applies this function to it. So you can see I've turned a list of integers into a list of strings. And now I'm going to do something really cool. So you can see I can actually chain these higher order functions together to do really cool things. So that is one way that you can make your code really concise. Is maybe it seems like one of these by itself isn't that useful, but we can chain them together to do really cool things.
All right.
Can I show one more trick?
Yeah, sure.
So actually, this is such a common use case that I think you can do something like, what is it?
Yeah. MK string is great.
MK string is very cool.
So Scala, by default, every object in the system has a toString method. And so you can print anything. Now, the string method may print useful stuff or may not, depending on the contents of it, but it means that you won't make a mistake by saying print the string out, and you can get there. And when you write your own classes, you can define your toString method so you can make it sure that it produces something useful.
Shall we move to the hardware example?
Yes. Do you have one in mind?
Yes.
Okay. Go for it.
I'm going to copy the scaffolding from one of the other modules. Is that okay?
You might want to just run those top blocks if you're doing any hardware things.
I was thinking of just copying the code too.
Oh, to the other section because I ran it.
Yeah, because you already ran it. So.
Okay.
So imagine, let's say you want to build a okay, so this is a really simple example. Let's say if I have a vec of kind of 16 integers, and so as we discussed, the vec is an example of a hardware collection. So one thing is, let's say, how do I express adding those 16 integers together and returning a output? So I mean, one really inefficient way is you could do io.out : equals io.in 0 plus 1, blah, blah, blah. So that's really, really inefficient. So one way you can do it using a for loop, but if you really harness the power of Scala collections, you can do something like, fingers crossed this works. See? You can build an entire an adder circuit for this collection in one line. Yes.
Yeah.
So the input to the input is that a constructor there?
What is this?
Yeah, the input not keyword.
Okay,
So we're constructing a bundle, which is the IO in this case.
And you're giving it a definition then.
Yeah. So the input says that it's an input thing, so that's just a marker that's going to be reflected in the hardware graph.
And this is a type. So.
But that's a Scala type, or is that a type in the?
That's
the
a hardware
Chisel
type. Vec is a Chisel type. It's a hardware type.
Yeah.
All right.
And so that means an array of, or a bunch of things in hardware that are indexable. And then the 16 this is a constructor, so it's building a thing that has 16 elements and defining the type of them.
Now, that's not actually building a thing with 16 elements in it, that's describing how the hardware would build that thing, just
Well,
to be clear on that.
yes, I mean, so this is another whole angle of Chisel is, and I think if we had to do it all over again, we might have done a little bit different here. So a uint in Chisel is two things. It is a type, and it also can be a thing. So you can have a 7 is a value, right? That can be a uint. It can be an unsigned integer. Those are both use the same construct, the uint construct.
And that's a different uint than the uint in Scala, or is it the same
So
one?
Scala doesn't have a uint.
Scala has no
Okay.
uint.
They have an int.
Oh, okay.
Yep.
Yeah. So Chisel has uint, sint. We took a peek at interval. It also has, what am I missing? Bool. And then the other there's a fixed point implementation now.
So these things are both the description for the types in the Chisel DSL.
Yes.
But you can also have values of them, is what you said?
Yes.
So it's something that seems a little bit kind of unusual to me.
Well, you
Usually-
couldn't. I mean, the values have to appear in a context where that makes sense. So, in an I/O, you couldn't put. It would complain, I think, if you gave it.
I think if you did something like, well, then that is obviously. Yeah, so you obviously you can't create, like, this is not a type, this is a value, so that's an error. So you can see the compiler is telling you, hey, this is illegal hardware.
So on your previous example with the 16 vector 16, so it creates 16 4-bit adders.
16 wires. Oh, the reduced
Yes.
operation.
Yeah.
Well, we could look at the result.
I mean, it's literally just taking 0 plus 1 plus 2 plus 3 plus 4.
Yeah, this is one of those things that, we were talking a little bit about, the abstraction costs and things like that. So this is taking the first element, adding it to the second, taking that product or that result and adding it to the third, taking that and adding. So you get it's an addition tree that looks like this.
But it builds physical adders for each
Yes,
stage.
right.
Yeah, I mean, the exact adders are synthesized by the downstream tools. Like Chisel won't synthesize.
It's not inferring any particular type of adder. Like there is no annotation that says I want you to do terrible ripple carry adder.
So this is a case where, remember one of my examples back in the beginning where Scala versus Chisel is the reduce works because it's given a hardware element and a plus operator, and that plus operator is a method of the uint. So when it tries to figure out what do I do with that, it looks at the code and says, oh, uint has a plus, and it takes that and it returns another uint. And so that uint gets passed down the chain, and this uint tree gets developed.
But it wouldn't add smartness to how many carryouts it needs to produce on the output.
No,
usually that's the domain of the synthesis tools. Like usually the synthesis tools will do that.
But here you're dictating on the output that you only want 4 wires, right? So you're.
Yeah, if I wanted to grow the output, there's a separate operator I can use I can have it grow to 5 bits.
And could you parameterize it that it does the right thing if you want to keep the carry depending on the variable input length?
Sure.
So there's like add and add ampersand, right?
Yeah.
I think add ampersand. Actually, let's do a simple example of that now that we've.
Yeah.
The additions here are done serially, but you can do like if it's 8 adds, you can have 4 and 2 and 1, and then it will be more.
There's a couple things. One is you could write your own iteration to do that in the way that you wanted. Reduce is not going to do that. There's been a lot of debate about this, and I'm not an expert, but synthesis tools recognize certain patterns like this and are very likely to reorganize those into a more efficient pattern. So in general, I think that we encourage people to write sort of naive Chisel in this sense and use reduction, and you get mux trees that are similar.
Like synthesis tools like DC and Genus are very powerful, and they will almost always be able to infer the right thing. And if not, then we can add physical design annotations to constrain them.
And this is also something that could be fixed up in a fertile pass, right? This is it's a pattern that's pretty easily recognizable.
And then you could also use a binary tree structure, because a list is just a list pass kind of baked into it. You want to do a linear iteration. That's an assumption.
That's right.
Yeah, but you can use something like scan and do them 0 and 1, 2 and 3 and
scan
function.
Or sliding or
So actually, I want to address the question of carry. So if you look at the simple code here, so the default add operator, I'm using it on 2 4-bit inputs. You can see by default it's dropping the carry bit and truncating into 4 bits. But there's another operator, I think it's like this, plus ampersand. And if you use that, you can see this one keeps the carry bit, so it returns a 5-bit output.
So it extends the bus.
Yes. So basically, this takes in like 4-bit, 4-bit, and then this operator returns a 5-bit result. But the default add returns a 4-bit result. So like if you basically we provide you, as a designer you can specify if you want the carry bits or not, the carry bit.
And if you tried to do with the carry, but you had 4 input bits, 4 output bits, it would be a compile time error?
I think by default it does a truncation. So you can see here this out is 4 bits, and this trimmed off the carry bit.
And it's silent, right? It doesn't give you a warning for data loss.
Yeah, so right now it's like the default behavior is truncation, and in the future we may add compile options to make that more noisy.
We're kind of moving on time. I'd like to do a little bit more of that, but maybe I'd like to spend a brief tour here. Where's my different window? I thought I had a.
Oh wait, go back.
Who's this guy? Yeah. So this is something recently we added, a little diagrammer that will, this is just a fertile pass that will walk over your design and build. This is a top level module map of a particular design. If you run this, there's a repo called Diagrammer in the Free Chips project. And if you just output your fertile from a Chisel design and run it through this thing, it'll generate this diagram. This diagram, each of the boxes is a link to the sub boxes that do that. So that it's another visualization tool. I wanted to do something here that uses the IDE. And I just like to find something. So this is IntelliJ. I use it quite a bit. It has it looks like pretty much all these things. The clips all look the same. You got sort of a list of the files down over here, which you can close and open up as you see fit. Not happy with that. That's unfortunately I'm in the wrong development tree for that to work. Chisel masters, Chisel testers. So this is the Chisel testers and has some examples that we can look at, but I just want to show some of the capabilities here, why I think this is useful. This is a typical arrangement of a project, the way it works. Talked about GCD a lot recently. No, that's not the one. So here's another module. Can you guys see that okay? I can make it a little bigger.
Make it bigger.
So the the IDE does a lot of things. It's got the pretty, the colorizing and stuff like that. But one of the real advantages is that you can, if you are on any element, and that element is some class, you can use on the Mac keyboard, it's a Command B, and it'll pop up something that lets you go figure out what that origin of that is. Now, with Chisel, it's sometimes a little complicated because there's a redirection layer in order to support backward compatibility with things, but it just means I might have to go a couple things. But with 2 clicks, I'm actually at the source code for a bundle and what it does, and I can look at the, members. I can say, oh, look, it's got this elements array in here, and it's got some documentation as to what it does. So it's just really easy to navigate. There's a key that takes me back along the path that I traveled. There's completion, so if, I don't know, there's not that much here, but if I made a list of some sort, So let's fill a list of uints. And then I want to say what what was the name of that thing?
What is that filled in?
Pardon?
What is that filled in?
That's filled with these would be like wires. Actually, well,
You want to wrap that in
yeah,
wire.
I'd want to make that a wire. So this is now a bunch of wires that you can connect to things. But I don't understand why it's not giving me some method signatures.
Do you have to construct the list first? Like I'm not. It seems like.
Fill is a thing that is a constructor. It fills it up with things. So that's a pretty common thing to use. I am utterly mystified as why that is not providing me with. So what I was trying to show is things like this with completion, where it offers me different things that I might want to complete that with. So
Do you have to explicitly declare it as a sequence? Or?
no.
No, the type inference
The type should be there. We talked about languages earlier. Go ahead and play with it. In general, and this is just sort of a classic demo failure, but the reason you go with Java is that one of the benefits of strong typing is that your development environments can also look at that typing and do the right thing. So that typically when one writes code like this, and I just mystified as to why it's not doing it right now, is when I click that period, it can show me the methods that are possible. And as I start typing, I can narrow it down. So I'm like, is it sliding or scan? I type S and I see the two things, and I can see the signatures and figure out what it is that they need. The other, so that's a really big win, is that the editor itself can make sure you're doing lots of sort of stuff correct right up front, and it will complain if you don't. The other thing you can do, and I don't know if this is going to work, is, for example, I can go to this I/O, and I can hit some magical key, which I will, and I can change that. Is that doing it? I'm not going to do it. Let's do it with the X. It's like the thing turned on me.
Try right-clicking on the X.
I don't have to.
Oh, I don't know.
No, it's the strangest thing. F6 is Shift X6. It's like the thing is.
I guess what I'm saying is you can also discover the function of you right-click on it and do refactor.
No, I was gonna. Oh, yeah, I see.
Yeah, you can access the same menu. You also have caps lock on.
It is just very weird. All right. Refactor,
rename.
See, it's not even doing it.
Oh, yeah, okay. Yeah, something is glitching in the IDE.
Something is completely glitched. Which is
I can attest to the fact that if the IDE is configured correctly, it will do the refactor and rename. I have done it many times.
Which is really nice, because now it'll take your thing and it'll rename it, and it'll find all the uses correctly in this entire project and rename them all. It's really useful.
Yep.
And I've even gotten into, more recently, using it in a way that it will, I can change the signature of functions, and it will do a pretty good job of figuring it out. There is some ambiguity in that case.
Along the lines of naming, is the variable names that you use, does that get propagated forward, or is that only visible to the Chisel front end?
Oh, the Chisel names are propagated through Fertile.
Yeah,
as much as possible.
As much as possible, and they'll show up in Verilog.
There are a couple exceptions to that.
Wait, so if I say val x or val io equals that will get propagated to because I know this is a common mistake when you use TensorFlow, is that there's an assumption made that when you name a variable, that's the name of the variable in the flow graph, and that's not the case. That you're building an object, but you can't get access without using a lot of reflection.
Are you talking about from a generating Verilog perspective? Or?
I mean, just in general, usually, unless you're using a heavy amount of reflection, you can't get access to the names of the variables at the Scala land level of things.
So yeah, so inside the guts of Chisel, there is some reflection going on. But like from a user perspective, you generally don't see that.
I gotcha.
But like if from an internal implementation perspective, there is some reflection.
Okay, just so I know I'm not insane. So X I've selected, I've said I want to alter it, and I'm going to change it to be dog.
Yay, it works.
Wow. Yeah, that was just ridiculous. It does a good job too if you want to, you're going to run, I guess that's all good. So it's a nice integrated environment, so you build your tests like we've discussed here, and
every time you open a new file, it becomes small again.
yeah, it's the default. It doesn't quite follow like the rules that other apps do, but yes. But I can build here's a bunch of unit tests we built for this thing. And so I can just right click in one of these things, or
No, I saw the menu.
It's just really slow for some reason.
And then run.
And then just run, and it'll run my unit test. So
Is your iPad notebook taking up some?
yeah, there could be something's rampaging in the background on my machine.
There's the test.
Yeah, so it's working. It's just God knows what that window is. Oh my God.
The profile.
I launched a profiler on that one, but
Yeah,
it ran my test
and
here
it passed.
And passed. And can I expand that text? I don't think I can. This is a very easy development cycle. We talked about another Scala versus Chisel thing. Is we use print lines to demonstrate a lot of the stuff there in the collections. Print lines are Scala, so they are going to print out as the Scala program runs. If you want to print out things that when your circuit runs, which only in simulation, of course, you can use printfs.
Yep.
So printfs will go at, when the circuit is simulated and do that, those are going to be popping up, and you can embed those printfs within when statements, and they follow all the rules correctly and all that kind of stuff.
Yep.
Really briefly, let's make a new one. So what do we have? Let's do. Okay. I was going to do the GCD, but I don't know. This is the Treadle. It's a Scala-based simulator, but it also has a REPL mode that you can go into a fertile design that you produced with Chisel code. This is the marvels of SPD starting itself up. So now I'm in the REPL. I can show like the fertile code that it was wrote. This is the GC application. I can poke things. So there's an IOA. Let's poke a 33. Poke IOB 22. We can actually chain these commands. IO enable. Oops. Poke there. Step. IO enable 0 to disable that. Step. Wait for IOV to be 1. Peak IOZ. So this is a GCD operation performed in the hardware simulator using peak poke. So I can step through this. I can turn on verbosity here. So I could run that same thing again.
Maybe step.
if I step, I'm probably not going to do anything that interesting, but here's all the individual assignments, taking, all the wires being assigned at their different values, looking at it. You can, there's a zillion things that this thing can do. You can actually accept the VCD input file, so you can use the VCD to drive the inputs and watch what happens as things go by. You can set watch points on different things and see how they're getting assigned and why they're getting the values they're getting. Let's see if there's anything else worth looking at here. This is the underlying thing that like the test we just ran in the IntelliJ is using this engine on the back end, but this allows direct access to that. What else? Talk about. All right, we got a few more minutes. Any other places you guys would like to go?
Match.
Match.
Or companion objects would be cool to hear a little bit about.
Oh, okay, yeah.
Can we play with that in the notebook?
Yeah. Although, if you want to look in Fertile, the match statements there are probably richer, but if you have a So companion objects. So I think most of you probably have a general idea of what a class is, and that just means that it's a way of encapsulating a series of variables and methods associated with them. In Scala, okay, well, we're here. So Scala provides another mechanism called an object, and an object is typically associated with a class. So like, lion, there should be if you have an object lion, you're probably going to have a class lion, although it's not required. And unlike a class, lion is a class, but it is a class of a singleton. There's only one instance of it, and so it has very different properties. Unlike an object where you have to have a handle to get to it, so you set a class there and say new lion. The only way to reference that thing is to have a variable that points to that reference. But with the companion object lion, you can just say capital Lion anywhere and then use the methods and the variables that are contained in that. So
you see, like in other languages like Java or Python, you might have static methods, but the way that Scala does it is through.
You just put your static methods essentially in the object because there's only one instance of them and they can do that. There's a lot of common usages of that. One of the main ones is that for a lot of classes, and particularly with complex parameterization, you can actually build constructors in the companion class, and those will generate classes, like in this case of lion, but have particular properties. So you don't have to remember maybe all the signatures. You just make a factory that says you want a lion that's an African lion or a mountain lion or whatever it is, and it will construct that stuff. And it's probably not a bad time to mention syntactic sugar, because you'll probably hear that by Scala proponents saying how great that is.
Should we talk about apply?
Yeah.
Okay.
So syntactic sugar occurs all over the place in Scala. The underscore is one example, as it's a handy way of referring to, to some previous reference like in the list management stuff. But the apply method is another classic example of syntactic sugar. Is if you have a method named apply, that method will be presumed to be referenced if you just take your object and put parentheses after it. So I think Edward just did this. So.
Yeah. So you see here, like right now, I defined this method called apply in Lion, and now when I just call the companion object, it calls this apply method, and see it printed roar.
Is it doing that only because you passed in a string, or it's just going to do that?
Well, I mean, so like the apply method, like this apply method is a method like any other, right? So it can take parameters. So I can delete that parameter, and it will work. So conventionally, from a stylistic perspective, usually this returns an instance of like this class. So you might do something like you might return a new, and then when you call lion, it goes.
You don't need to use the new keyword. So it's just
well.
Why did it take the
I think in this
apply
you want to
not
create
the
the class.
Why did it take the apply not the roar? But just because the name of it is apply, or because both have the same inputs?
So you're saying like why does it know to use this method?
Yeah, not roar, because both have the same inputs.
Oh, it takes it by name. So like the name apply is what this will call.
I see.
Yeah.
I see.
So that's how like a list constructor would work then?
Yep. So inside Scala, you might imagine it looks like something like, and then lots of.
My next question is actually the harder follow-up question. How do you do like a variable argument function like the list factory then? Because that wouldn't be
like var args.
It uses something like that, I imagine,
yes.
right? Because if you're using a statically
yeah.
typed language, one of the classically hard things to do is have
yeah.
variable numbers of parameters.
Yeah. Scala has a var args mechanism, I think. I don't remember what the syntax is. I don't.
But you almost never use it. You would just say args colon
right,
array
yeah,
of something.
So
the only trick about that is.
Like there is a way to do the variable.
Well, no, but it only comes up if I make some method here, which takes args, which is an array of string.
No, but you need to put a seek around it.
Well, you don't. So
it will do it automatically.
Oh, I see.
I think this will give an. Let's try
yeah,
it.
No, you're right. That will.
Well, if we run it, yeah, it's gonna tell you it's. You need there's like a little. Can I drive quickly?
Yeah, sure. You could do the colon underscore splat.
Yeah, I think what you need to do is.
I'm just kind of curious. I can always look it up as well afterwards.
See, that's,
yeah, it's this thing.
No, but that's how to pass things into it. That's not how to define it to be a.
Yeah. I think you just put a star next to it.
That's right. You put a star.
Where is it?
So just put a star.
I think it's like
at the end.
Star.
Yeah. So that works.
And because it has self-typing, you can have heterogeneous.
Yeah, you could. Well, you would have to make the type be any, and that's
right.
Yeah, introduces a naturally to match. So let's talk about match. So why don't you change that to any?
Yeah.
Okay. Thank you.
So should we demonstrate match?
Yes.
So I guess we can do. I think you have to do map, right?
Well, just do for each for now, and just print the types.
I think it's like
and zip it with index just for the hell of it.
So zip with index.
Yeah. So this is going to be each argument. No.
I think we have to do for each.
Yeah.
It's like.
Well, for each is an implicit match, so it's kind of.
We can write the match explicitly.
Yeah. Let's just do matches.
So it's like lm.
Yeah.
We can write lm match.
Yeah. You're good. I think you need that extra parenthesis. Oh yeah. Go ahead.
Okay, so you can do something like case
string
x.
Yeah.
And then you can case and int case. And then you can also find and then you can now call these with
You have x.
I think you're missing a
case. Yeah, see? So you see it string, in bool.
Okay.
And if you passed in some other kind of object, it would probably just choke or something like that.
It would give you an error.
Does the case respect subtyping? Does it try and find out, or does it go for an exact match?
I'm sorry.
Because we have subtyping, do those have to be an exact type, or does it have to just be if it's this type or a subclass?
A subclass you have to be. Order matters there. So if you tested for the subclasses first, excuse me.
Yeah.
Then so you would write if you cared, you'd want to write in the order where it wouldn't.
Yeah.
You wouldn't get match it.
It's
I'd like to do one. You have a question?
The case is of x, z. That doesn't really matter what you put after that, whether x, z, or whatever it could be.
What's that?
Whether the case x or case z matters?
No. Well, this is a variable name. So what match is doing is it's assigning a variable here.
So what you can do is you can use that variable.
Yeah.
So you can see.
And
So yeah, it's plugging in. Now, I'd like to show another stupid match trick. So sometimes you end up with this is a really common case, is you essentially have a truth table, right? You have two values. Do we have X's and Y's here? Let's just do a truth table, or these probably be functions, right? How about T returns? So one thing that's cool is if I do T comma F match, then I can fill this in with a bunch of cases. Well, I'm doing this in not the traditional way, but
I have the same case.
I know. Well, I wanted to order it the way you probably would usually do this, and then.
You kind of exhaustively match all the possible
Right. So
cases.
what I'm doing here is I'm creating a tuple with the elements being these two function calls, and I should really.
Can I make a change? Yeah. I was like, there's one easy way we can make this.
Okay.
So probably one useful case is if we just.
Can you return a random? We'll just do.
And then we can return in. And then we can call things like myfunc. That returns a 1, and then if we call true false, then that returns a 2.
Yeah. Okay. So did you guys follow that there? So you can call this function now, and it takes the two arguments, makes a pair out of them, and then tries to match that pair against these possible match values. And so what it does is it just searches through this table linearly, and when it finds an entry, it executes the code following the arrow.
Can you do default when you don't match, if it's not fully exhaustive?
So yes, for instance, like if this last case, if I don't want to distinguish between the two of them, I can put our friend the underscore here. And so now any of the false cases.
You can change the first parameter to false.
I think you need to change the second one to an underscore rather than the first because you've already covered all.
Yeah, I've already covered the truth. You're right.
And you could replace the whole tuple by an underscore if you wanted to just catch every other case regardless.
Yeah.
Of
You can do case underscore, and that just
case underscore means catch any possible thing. And so here, so this the two false ones. Well, I'll make it under. These would all return the last two return 2 because they wildcard on that. The other cool thing we talk about syntactic sugar. So if I make a case class, this is a class. So this gets some methods for free. So now I can say val x1 equals x1 comma 2, val y1 equals x, I don't know, 4 comma 5. So another way of doing this, let's just say x1 match case x a comma b. Well,
you can do string interpolation.
Yeah, just a equals $a, b equals $b. So this is not elegant here, but I wanted what?
Case class x.
What? Oh, no class. So this is a really cool property. Because I made this a case class, x and y are accessible as public methods of x, or publicly available variables of x. In this example, x1 is a class, an instance of x with the value x1 and y2. this match says take x1, match it against this, and this is what this thing is doing is creating variables a and b that are matching x1. So this could be more complicated, like you usually want to distinguish. So let's say here let's do the case where it's I can actually have it match these cases. So it will only match this line if x is 1 and then b is going to, yeah.
So we can,
Yeah.
well, okay. Sorry, I
Yeah.
practiced DRY.
That's fine.
And now we can call this function on x1, try on, did I mess up? Oh, a doesn't exist anymore. Yeah, see, you can see it was able to distinguish between the two cases.
Right. So this is another thing that we call use of syntactic sugar, the ability to match on a class and get variable elements out of it by this sort of match procedure.
One other cool trick is that you can actually omit this outer paren, so because a statement can be a full definition in Scala. So you can almost put this Q match onto the same line, and it's very concise now. Yeah, sorry, minor trick, but just little things like this make Scala fun to program in.
Right. And this whole matching thing is built into most of the list operators. So if you say, do we have a list here? We're probably way behind. If people need to leave, I would certainly. So list for each, which ordinarily one would write something like x, then do this for x, but we can actually do case statements here. And so a, and you can even put guards on this thing. If a mod 2 equals 0, in this case, print case, otherwise okay, well that should run, right?
We're going to do val list instead of LL.
And maybe an LL there too. I don't know if that.
It's very cool.
So in your list, you can actually handle lists that have different things in them by using this match construct, the implicit match construct with the all of the case statements.
Is that like trying to handle different bundles with different metadata attached to the bundle or something? Or I'm trying to understanding hardware.
Why you would do this?
Yeah.
I think that's one example. Yeah, in the Fertile side, this makes like parsing and doing compiler work just unbelievably easy. But there's a lot of cases like this.
Well, I mean, okay, one naive example is, let's say like I have a list of tiling nodes. Some of them are input nodes and some of them are output nodes. I can do like my nodes dot for each case input node do something, case output node do something. So that's one example of how you might use it in Chisel land.
Mm-hmm. Yeah. It also lets you write. So one of the big advantages of code generators is you might want to write modules that take that parameterize types. And a lot of times, like if you're just adding types together, as long as the types are uints, they'll all add. But there may be cases where you need to know if it's a uint or sint because you're going to do something different with the sign bit. Okay. And so there you would match on the type and say if it's an sint. So you're in your IOs, you would say IO equals X is of type T, and so T is passed in as a parameter. Okay. So your module works on T's, not on uints or stints explicitly. When you create the class, you say I want to create that class using where T is uint or T is sint.
Yep.
A lot of stuff will just work, but there may be special coding, in which case you would say, X match sint do this, uint do that kind of thing. So it's a way that you can handle things where you don't know the types at coding time, or you don't know which type it is for that instance. I'm sure lunch is out there by now, right?
Yeah, it starts at noon, so it's now.
Okay, well, I
Yeah.
appreciate you guys sticking with us. I hope that was useful. I mean, it's just a lot of stupid Scala tricks, but it's good to know, it's good to see, it's good to know. So if nothing else, you know the takeaway, these things are out there. You know a little bit of stuff when you see it, when you look at some Chisel code, maybe it'll click, oh yeah, that's that kind of thing. That's a list comprehension or a collection method. I know how to categorize that, and then I know how to look at it and figure out what to do. All right, thank you very much.
Thank you. Can I ask you one stupid question?
Oh.